Okay, hello. We are ready for notes 4.5 here. In the previous section, 4.4, we had those two theorems, side, 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 and side, angle, side. Today we're going to do three more. There's three more to add to this list. This first slide reads, an included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. This green right here, I'll highlight it in red. It's between this angle and this angle. Again, it's between. And that's what included means. In the previous section, we talked about the included angle. And that was my side, angle, side. This time we're talking about the included side. Next slide. And here is my next one, my next postulate. Angle, side, angle. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. If you look, A and D go together. F and C, there's two arc marks there. And look carefully, see the side in between them? That side and that side. I just circled the tick marks. The side in between them are congruent as well. So again, that's angle, side, angle. The side is between the two angles. The next slide, determine if you can use angle, side, angle to prove the triangle's congruent. Well, remember the concept of the shared side? And that shared side would be right there. Well, if I draw these separately, or attempt to draw them separately, let's mark this again. Here's two arc marks, and there's two arc marks, and then this angle and that angle. Then I'm going to use black to mark that side and that side, which is my shared side. So can I use angle, side, angle? In other words, is that side that I have marked with a black tick mark, is it between the two angles? My answer is no. The side I would need to have would be this side. The blue double tick marks are the sides between those two angles. So as it stands now, my answer is no. I could not use angle, side, angle. Let's look at the next one. Determine if you can use angle, side, angle to prove those two triangles are congruent. Well, notice your diagram, you have parallel. So I can mark this angle and that angle are congruent because it's two parallel lines cut by a transversal. And then I can also mark this angle is congruent to that angle. And also I can mark the side in between. I'll mark that with a tick mark because that's a shared side. So what I want to do is draw these triangles separately. Here's the top one, and here's the bottom one. Let's label this K, N, L. That's L. There's N, and there's M. So again, I'm just pulling the two triangles apart. This angle would be congruent to this angle. And then this angle here, one tick mark, I'm sorry, arc mark, and then of course my shared side. So sometimes, or oftentimes, it helps to see the triangles drawn separately, draw them apart, pull them apart. Okay. Now, are they congruent? The answer this time is yes. Because you see these tick marks there and there are between the two angles. This angle and that angle. This tick mark is between, and this angle and this mark. It's between. So my answer here is yes. Why are those two triangles congruent? I would simply say angle, side, angle. The next slide is a different theorem. This time it's AAS. And this one reads, you can use the third angles theorem to prove another congruence relationship based on angle, side, angle. This theorem is the angle, angle, side. So the letter S is not between the two angles. And it reads, if two angles and a, circle this word, non-included, so it's not between, side of one triangle are congruent to the corresponding angles and the non-included side of another triangle, then the triangles are congruent. If you look carefully, I see an angle, angle, and then I see this tick mark. It's not between the two sides. Same thing here. Angle, angle. This tick mark is not between. The word is not included. So angle, angle, side. We have another theorem. This one is just called HL. And that stands for hypotenuse leg. This theorem only works in right triangles. Where everything we've done up until now, has been any kind of triangle, this HL theorem only works in right triangles. And it reads, if the hypotenuse and a leg, HL, of a right triangle, circle that word, are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So your hypotenuse would be this double tick mark there and there. I'll circle those. And a leg would be that tick mark and that tick mark. Notice that both triangles drawn there have that little box in the corner, and that tells me it's a right triangle. So go to the next slide. Determine if you can use HL congruence, hypotenuse leg, to prove the triangle's congruent. Well, I have two right triangles. I have a left one and a right one. And it looks like I have the hypotenuse, this and that would be my hypotenuse. And I have a shared side in the middle. I'll put a double tick mark on those, which is a leg. So my answer here is yes. Both of my hypotenuses are congruent. And the shared side in the middle, that's a leg. The legs are congruent. So yes, I have hypotenuse leg. Skip to the next one. Determine if you can use the HL congruence theorem now to prove these triangles are congruent. Well, first of all, double check that you have right triangles. And I do. I see the two boxes in the corner. And it looks like, circle that one, that's hypotenuse and that's hypotenuse. So I have the H part of it. Do I have a leg? I think this shared side right there, it's shared, so it's congruent to both of them. That is my leg. So yes, these triangles are congruent. Why are they congruent? Because of the HL congruence theorem. HL, hypotenuse leg. If you go to the last slide, identify the postulate or theorem that proves the triangle's congruent. My choices are side, 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 angle, side, angle, side, angle, 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 side, and HL. I have 5 choices. So let's take a look at the first one. Number 1. I want to see if that top triangle is congruent to the bottom triangle. Well, I see this tick mark here. That's a shared side. And I see 150, 150. So I'm going to put an arc mark there and there because they're both 150. And then look over to the right, I see 15 and 15. So I can put double arc marks there, double arc mark there. And it looks to me like that side is between the 2 angles. So I would say yes. Number 1 is congruent. Yes, they're congruent. The side is between, so it's angle, side, angle. Number 2, I see 90 degrees and 90 degrees. So I'm going to go ahead and put the boxes in the corner. And that tells me I'm going to lean towards HL. But let's see. Do I have the hypotenuses congruent? That's hypotenuse, so they're congruent. And now do I have a leg? I sure do. Legs there, leg there. So are these congruent? Yes. Why are they congruent? Because of hypotenuse leg. Now let's do number 3. Even though those 2 triangles look like they're right triangles, I don't know for sure because they're not marked. They're not marked with the box in the corner, and they're not marked with the 90 degrees in the corner. So I cannot assume they're right angles. So that means that HL is out. I cannot use HL because I don't know if I have right triangles or not. But it looks like I have side and side. But if you look right here, this arc mark here, I could put another arc mark right there because of vertical angles. And I could do the same thing on the other side. Arc mark right there because of vertical angles. So it looks like the angle is between 2 sides. So I would say yes. These triangles are congruent because of side, angle, side. Again, because the angle is between the 2 sides. So the letter A goes between the 2 S's. Make sure that you have this list of these 5. By the way, we will not add any more to that list. We'll stop there at those 5. Make sure you have that list handy of those 5 abbreviations. Hey, thanks for watching.